Hi Year Fives and welcome to your geography lesson. We're going to be looking at how an earthquake forms today. And our big question is what makes the world shake? So could you please write that date and the other and your big question on your piece of paper? And this is just about what we're going to be looking at as our steps to success. So can we describe how an earthquake is formed? Can we describe how an earthquake impacts the environment? Can we identify ways to keep safe during an earthquake? And can we name the instrument used to measure an earthquake? Okay, so those are some of the questions you need to have in your mind when we're going through the slides, so that you can be able to answer that to know that you have successfully understood this lesson. Before we get going about learning about earthquakes, can you please do your just checking? So you can divide your page into 4 and you can answer these quick questions. So last week, what do we call the lines that run from north to south? Name the line that divides the earth into northern and southern hemispheres? What is the name of this landmark in Brazil? And can you please circle this vocabulary? It says, which word means an instrument that shows direction? Is it a globe or compass? Tick the sentence that uses the word atlas correctly. So you can just choose sentence 1, 2, or 3. And again, just write the word which is closest in meaning to grid. Okay, so if you can please pause the video now and write that down, and then we can go through the answers together. Super, let's see how well you did. So the lines that run from north to south are called your lines of longitude. Remember, we still said that they are very long, they're going down. Then we said name the line, it is the equator. Name this landmark, it is Christ the Redeemer statue, okay? And this is what we're going to be looking at some vocab today. Right, an instrument that shows us direction is called a compass, and we learned about that word in our previous lesson. The sentence that uses the word atlas correctly, an atlas is a book of maps. So my atlas has maps of every country would be the correct answer, and a grid means squares, okay? So hopefully you've done really well with your just checking, and that's ensuring that you've understood what's been happening in your prior learning. Let's move on to what we're going to be looking at today. So we're going to have a quick recap of before's lesson. So we're going to look at, see which key facts we can remember. So can you remember how many main islands Japan has? What is the capital city of Japan? What is the ocean to the east of Japan? And can you name the country that is near to Japan? So pause the video now and have a quick go at answering those 4 questions. Right, hopefully you managed to do really well and you have given some of those an answer. Remember, this is all previous lessons work. So this is work that you have been exposed to, you have learned, you have seen. And if you are keeping your geography together, if you go back and have a look, hopefully your answers were there. So there are 4 islands. The capital city is Tokyo. The Pacific Ocean lies to the east of it. And any one of those you could have given as an answer, okay? You just had to give me one country, so any one of those answers, you were really paying attention to your first geography lesson. So well done. Right, so let's have a think. Can you describe what an earthquake is? Where do they happen and why do they happen? Okay, so have a think about those questions and have that in your mind as we go forward. So just have a real little think about those. Okay. So what do you already know about earthquakes? These are not in the correct order. So can you now put these sentences into the correct order? So which one would go first? Which one would go second? Which one would go third? I don't mind if you just actually talk about this because this is not really your activity and we have done a bit of writing already with your just checking and the recap lesson. So you might want to just have a read through of these and decide verbally which one do you think would be first, second, third, or fourth. Okay, and then let's have a look. Right, hopefully you managed to have a think and you get you going and you would understand that this is the order in which they go, and that is what we're going to be looking at today. So if you've got all of these 7 correct, then you are a whiz at earthquakes and you obviously have a lot of knowledge about this. If you got 1 or 2 incorrect, then you're doing still very well. And if you got more than those, then let's have a real think about how an earthquake, what the order of an earthquake looks like. Okay, so it's very important that we need to understand the structure of the earth. So this is what the earth is made up of. It's made up of 4 layers. the crust, which is this top layer, which is the smallest layer. Then we got our mantle, which is underneath. And then we get our outer and our inner core, okay? And each layer is made up of a mixture of solid and liquid rock, getting hotter as they get closer to the planet's core, okay? So at the center here would be the hottest. The crust is a solid rock on the outer layer of the earth. And that is what we are standing on right now, okay? The crust. The crust is not one complete layer though. It's not just one that's been wrapped around, okay? It actually is like a puzzle piece. It's got a whole lot of little pieces that join together, and we call these pieces tectonic plates. And these plates are constantly shifting. They're moving all the time, okay? Now they're not moving very quickly. They're moving quite gradually. So some of you might not, that's why we don't feel that we're moving on the plates, okay? But they are moving. So here we have the different types of plates. So you can see the white is the continent, and underneath these are the plates, okay? Now we are on this plate here, the Eurasian, and this is our little country there, all right? And you can see that we are quite in the middle of a plate. But you will notice that there are these little arrows, and these little arrows are showing us how these plates are interacting with the other plates nearby. Some of them are pushing away, and some of them are coming closer together, all right? And where they come close together, this is where we often see, our earthquakes, we see volcanoes happening, all right? And can you see there why volcanoes would be so common and earthquakes, not necessarily volcanoes, sorry, but earthquakes would be very common in Japan, okay? So have a look there at the tectonic plate and see what you can see and notice about what's happening in that picture. And hopefully you would have realized that the two plates, they are coming together, and that is causing an issue with and resulting in earthquakes. So let's have a look at why earthquakes happen. So when these two plates come together, they are often passing one another, okay? And when they come together and they cannot pass one another, they become locked. So imagine your fingers are two plates, and they're drifting together over time, and now suddenly they come together and you can't now push your fingers any further towards each other. Something has to happen. So this friction causes this pressure to build up. When you push your two fingers together, you can feel that there's pressure between your fingers. And suddenly this pressure has to be released. And so what happens there is the plates have to shift suddenly, okay? And they have to then, suddenly they'll shift into a new position. And this is what we call seismic waves. And these vibrations are called an earthquake taking place. Now, these plates can move in different directions, and we're going to have a look a little bit about that in more detail. So here you can see the two plates coming together. All right, these plates, this first picture here is where the plates are moving side by side. Okay, they're moving up and down. Okay, and the friction that's been caused between them. You can see in the next picture here, you have one plate that they've come together, and then the one plate moves up and the other plate has to move down, or it can be the other way around. Okay, it could have to come together and then this plate will move up and this plate will drop down. You can see in this picture here, the two plates come together and then they push up, and that's where we form mountains. Okay, that's how mountains are formed. And we can have the opposite where they come down and then they drop down, so that often we'll see rivers forming. Okay, so you can have a little read through that, all right, and you can see a little bit more about how those plates can interact with other plates. Okay, it's not just that they do one direction only, there are different ways in which they can move. Right, so we call, if the epicenter where the earthquake began is underwater, the energy created by the earthquake can cause a secondary natural disaster, which is our tsunami. Right, and a tsunami is really, really big waves, right? And tsunami in Japanese is built from two words called tsu, which means harbor, and nami, which means wave. Okay, so what happens is when these two plates come together and they suddenly shift, they will then cause this friction to occur and this drop, and then that's how an earthquake will then take place, and that is at the center of where it's taking place. And then what happens is that when this suddenly drops, the water, if they are under sea, something has to happen. And so the water then will also then cause a big wave, which is called a tsunami. Okay, so you can see here Here are the two plates coming together. They have now, the one has dropped and the other one has risen. And as a result, boom, this massive drop very quickly has now created this wave to build up, and then it will make its way towards land. So during an earthquake, the ground shakes back and forth, okay? If you're standing and you're feeling like you're having an earthquake, you're experiencing an earthquake, your body will be going back and forth and the whole area will be shaking violently. This is a lot of energy and movement are measured with seismometers using what we call our Richter scale, okay? So one of our steps to success was how do we measure an earthquake? We measure it on the Richter scale. This measures the magnitude of the earthquake and how powerful it was. Now in 2011, there was a really big earthquake that took place and it measured 9 on the Richter scale. So you can pause now and you can have a bit of a read here about the different effects. So you can see that anything under 2 is not, you don't really feel it. It might be like a little bit of a tremor, but anything over 8 is really big, massive distractions. There will be waves moving through earth visible with a naked eye. So you can actually see everything moving, all right? You can even go and Google some earthquakes, some videos and have a look at the impact of an earthquake on a city. So because of its location and the fact that it is on these two tectonic plates and they are constantly moving, Japan is what we call very susceptible to earthquakes. So they often get an earthquake, and you can see there in the picture the devastation of an earthquake. And so in March 2011, a huge earthquake hit the main island, Honshu, which later triggered a tsunami, okay? And you can see there the devastation of that area. Because it's located on the boundaries of 4 different tectonic plates, okay? It's got 4 different tectonic plates that it is on. Therefore, it is going to have to, they're going to be experiencing earthquakes quite frequently. Sometimes they have as many as 2 to 3 a day, but fortunately, most of them are small and they don't really go noticed. But to reduce the amount of damage, Japan has put in what we call preventative measures, so ways in which we can try and prevent the damage from taking place. Now, can you have a real quick think about what you could do to make sure that you are safe during an earthquake? So have a little think now and think about what you could do to keep safe. So there are some various ways in which you can keep safe, okay? So this is what some of the people in Japan have to go through. Now, if you are in school, you would have to do what we have fire drills at school. You would be doing an earthquake drill, okay? And they have to practice what they would need to do in the event of an earthquake, right? So they have earthquake drills to practice what to do. And this is usually the drop, cover, hold on rule, okay? So you need to drop to the floor. You need to find somewhere where you can crawl under that is a suitable cover, okay? As well as covering your head and neck with your arms. So you need to put your hands over like this, and then you would hold onto the cover you have found, okay? So hopefully that we don't have to experience that, but if we were at school, perhaps I would be getting under your desk so that any sort of part of the ceiling that might fall would fall onto your desk and you would be able to try and be as safe as possible. They've also designed buildings which are much stronger, or it can move, all right, with the ground. And this reduces the number of buildings falling apart and minimizes the amount of debris falling, which is one of the main causes of injury. Debris is like anything that has been broken off. Like if the building is crumbling down, obviously pieces will be flying around. And you can see here the different types of vibrations that they get and how the Japanese people have designed a building that would allow the building to actually move. Quite amazing, okay? So you could have a little look at those pictures. Right, so we have to also think about how we can predict an earthquake. So we need to predict, we need to plan, and we need to protect. So these are just some of the ways we can predict. You can pause the video if you want and have a little read, okay? And you might notice some of these things you've already learned about. All right, we need to plan. So if we are in an earthquake, what can we do? We need to have an emergency plan. We need to practice those earthquake drills at school. Okay, we need to make sure that our buildings are as safe as possible. We might even want to make sure we have our first aid kits ready. And as we said, we can make sure that we do our drop, cover, and hold on rule, okay, to protect ourselves. So those are just some of the ways in which we can keep safe when we do experience an earthquake. So some of our vocabulary: an earthquake is a very sudden movement in the Earth's crust. Focus is the point underground where the Earth starts. Epicenter is the point above the ground where the earthquake starts. And shock waves are the vibrations that you feel from an earthquake. So some of your vocabulary that you will need to know. Right, so your activities today are very similar for each group. So you've got 2 activities that you're going to be doing for me. The first activity is I would like you to explain and describe to me how an earthquake is formed. Now, if you're doing the bronze, you can just draw pictures to show me how an earthquake forms. So you can use those tectonic plates coming together, use arrows to show the direction, right? And if you're doing the silver and the gold challenge, you are then going to be describing it to me in a paragraph. You're welcome to go back in the video and go and use some of those, use the pictures as well to describe it. So you can draw the pictures and then label it and describe it next to it about how an earthquake forms, okay? And just show how the plates move and how this then causes an earthquake. All right, and adding any other information you would like. So you can pause the video now and do that activity. And when you're finished, you can come back to this page and to listen to activity 2. Right, so hopefully you've all completed activity 1 and now you're going on to activity 2. All of you are going to be doing the same activity, all right? And then at the end, there is a raft for you to complete. So let's see what we're doing. Right, this is a typical classroom, okay? Now, in this classroom, there are lots of things that could harm you during an earthquake. So I would like you now to have a think about all the things that could really harm you, all right? And write them down. So what could happen? So for example, this planet could fall and hit somebody on the head, all right? So how could I make this classroom a safer place to be? So what you will be doing is you'll be writing what could cause harm, all right? And then next to it, if you would like to challenge yourself, what could you do to make the items safer? So for example, there's this bag here and you might be standing and you might trip over it. So this might be something that's quite dangerous and will cause you harm during an earthquake. So how could I make sure that this is out of the way so that it is safer? So you can have a go there and then I'll give you some suggestions afterwards. So see how many you can find, really challenge yourself. See how many items you can find. There's a hot cup of coffee here. All right, there's lots of books. There's a big pot plant right at the top shelf. Okay, so have a think about all the things that could be damaged during an earthquake, even the windows, okay? What could happen during an earthquake with the windows, and think what's in front of the windows. So have a go at that and then see if you would like to challenge yourself of how you could make those items safer. So pause the video now and then you can come back to me when you're finished. Okay, let's see how well you did. So here are a number of items that have been circled that could cause danger. All right, so here are the hazards, so things that could cause harm. So we listed them there. All right, why would this cause harm? Okay, well, for example, that pot plant that we spoke about on the bookcase at the top here, it is very heavy and it could fall. So we should rather move it to below someone's head height, because if I was standing underneath this bookshelf and the next thing an earthquake hits, this pot plant could fall on my head and it could knock me out or cause me a lot of harm. So I would move this pot plant to perhaps more of a safer level so that if it did fall, it's not going to fall on my head. Okay, so there are some suggestions for you. Hopefully you've managed to get the same and maybe you found some others, but there you go, have a go. And don't forget to send your work to year5@theprimaryacademy.com email address. We'd love to see it. And that is all from me for today. So I hope you enjoyed your geography lesson. You learned some things about earthquakes, and I hope you enjoy the rest of your day. Bye-bye.